Hey folks, so let's together walk through this tutorial of leveraging the Nx standalone project setup together with Angular. So what are we going to learn in this tutorial? So first of all, we are going to understand what such a standalone project setup is about. It is basically a single project workspace, just similar to what the Angular CLI generates for you. We're going to explore how to serve the app, build the app, and what other things come with an Nx Workspace setup, such as built-in linting, prettier configs, as well as Jest tests or Cypress tests. We're also going to see how to leverage code generation to facilitate the creation of new components and even scaffold entire libraries. And talking about that, we're also going to have a look how to modularize your code base together with Nx. So let's go. So as a first step, we create a new Nx workspace. And we can do that by using npx create Nx workspace. I usually append here the at latest to make sure I grab the latest version. It's not being cached by npm. Then let's call this my ng app. And I could just then hit enter and go through the process of answering a couple of questions, choosing Angular as my framework, and so on. Now to kind of shorten that a bit, I can directly give it the preset flag here and name it Angular Standalone. So this will now ask me specific questions for the Nx standalone project setup with Angular as its framework. Note that you could also pass the --pm to provide a different package manager. Now we are going with npm here, but you can totally also use yarn or pnpm. So this first question here we get which style sheet format we want to choose. I'm just going with plain CSS now because it's not really relevant to this tutorial. Would you like to use standalone components in your Angular application? Now, if you confirm this, you will use the Angular standalone API rather than using ng modules. So definitely let's go with that one. Would you like to add routing? Sure. Would you enable distributed caching to make your CI faster? Now let's confirm this as well. So what this does is it allows you to distribute the NX cache remotely, and it is specifically interesting in CI. But we're going to talk about this a bit later. So for now, let's just confirm this, and we'll now get our workspace configured. So if you open up this workspace now in VS Code or whatever editor you prefer, this is the structure that we will get. So first of all, you can see already that we have a source folder at the root here, which is very similar to what the Angular CLI would generate for you. So you can see here the apps folder, there's the app component and a couple of other things that we told Nx during the setup to generate, such as the routes here. You can also see this end-to-end folder up here. And this is a Cypress-based end-to-end test setup that has already been configured to be run for our application here, for our main application. Furthermore, there is prettier set up for you, there is Jest already set up for you, and there's also linting, and specifically also Angular linting configured for this workspace. Now, what might be particular here specifically for you if you compare it to an Angular CLI setup is that first of all, you see that NX.json. Now, the NX.json is the metadata file that helps Nx understand your workspace better. And so one part here is, for instance, what operations are cacheable. And we'll talk about caching later, but this helps greatly reduce the computation time needed for building, testing, and relinting your workspace, for instance. There might also be defaults for your generators further down here, where you can specify like what style you want to use for the application generator, and similarly also for the library generators. And you could add more to these. Another particularity is there is no Angular.json. So Nx compared to Angular uses single project JSON files for potentially multiple projects in the workspace compared to one gigantic Angular JSON. And this greatly also helps avoid merge conflicts, which is especially happening when you have multiple team members working on the same project. In terms of the structure, this is very similar to the Angular JSON. And if you're coming from that, you should immediately be feeling at home here. So rather than an architect's node here, we have a target nodes in Nx, which specifies basically the targets that you can run for this application, which can be here the build, the serve, there's some extraction for i18n, there's the linting, the test task, there's even a serve static that just uses an HTTP server to serve your pre-built Angular application. Even if you look inside this build task here, for instance, you can see it's very similarly structured to what the Angular CLI uses. So there's an executor, which would be the builder for an Angular JSON file. And this one directly refers to the Angular Dev Kit builder that the default Angular CLI setup also uses, plus the options that come with it. So how do we serve our application now? Well, if you go to the package.json at the root of our workspace, we have already a couple of scripts there. So we could simply run npm start, npm run build, or npm run test. And what behind the scenes will happen is it will invoke nx to serve, build, and test application. So instead of going via npm, we could also just use nx directly. Now, I don't have nx installed globally, so what I do is I prefix it with npx, which would directly use the locally installed nx version in this workspace. So I can just do npx nx serve, and this would now serve my application. Since there is just one in this workspace, obviously, it would directly serve this one. And if you go to localhost 4200, we then see our application show up in the browser. So the syntax with which the nx commands work is very similar to what the Angular CLI does. So it is nx, then the target that you want to run, and optionally the project that you want to run. Now, in such a setup that we have here, so which is a standalone nx setup, there is just one project to run right now, and so we can omit that, and nx would use that default project directly out of the box. So knowing that, we can now also run linting testing for our workspace. So we can again use npx nx test, for instance, and this would use the jest setup for our application and run it here directly. And similarly, we can also run the linting, and this would now run the Angular linting and ESLinting directly on the workspace. And we can also invoke the end-to-end testing with Cypress that we mentioned before. Now for Cypress here, you can see that end-to-end folder, and this is kind of like its own project because you can see here there's a project.json. Now the project here specifically is named end-to-end and has a target end-to-end. So meaning if you run this test, we run npx nx, the end-to-end target on the end-to-end project. You're obviously free to rename this to something different. But what here would happen is now our application gets bootstrapped automatically, and following to that, the Cypress tests are ran against that project. You can obviously pass the -- watch flag to run Cypress in an interactive mode so you can directly inspect the test run, which is especially helpful in case of errors. Now we've run those tasks individually, but you can also run multiple of them at the same time. And so for that, nx comes with a run many command, and then we can give it a -- target or just short -t, and mention here, for instance, we want to run the build, the test, and the lint task, and we could potentially add more here. And so if you hit enter, it will run these now in parallel as much as it can for the entire workspace. You can also notice here already a difference in that some of the tasks, for instance, the linting and the testing of our application, have already run before, and so they didn't execute again, but rather they got pulled out of the cache. And this is one feature that nx comes with that, for instance, the Angular CLI lacks, is the ability to cache your computation. For instance, if I rerun all of these commands again, none of them would be rerun because we didn't change any crucial inputs such as the source files or environment variables. And so all of them got cached and therefore are extremely fast. So nx also comes with code generation capabilities. So not just to generate the initial project setup as we did with the Create Nx workspace, but also on the go. For instance, to generate new components, to even generate entire libraries, or just augment an existing project with, let's say, Storybook or Tailwind support. Now, to understand what capabilities there are, we can leverage the Nx plugins. The Nx plugins are those that contain these type of generators, executors, or even automated code migrations. Now for Angular in particular, we can find these plugins if we go to the package.json at the root. And here we can, for instance, see the Nx Angular plugin, which is just an npm package containing these generators and executors that are helpful for Angular development. Further down here, we also see packages for Cypress, for Jest, JavaScript and TypeScript support, linting, and so on. So to understand what generators come with our Nx Angular plugin, we can just use the nx list at nx Angular command, and this will now list all the executors that are built into this. So these would be the equivalent builders in the Angular JSON file, or also all the generators that we can use with this Nx Angular plugin. So if you would want to generate a component, we could just use the nx generate command, or short just g, give it the name of the plugin, which in this case is at nx/angular, and the name of the generator. So in this case, it would be component. And then we give it the name of the component, which let's just call this hello world. We can pass a flag such as standalone to create a standalone component rather than one that needs to be attached to an ng module. And we can pass further flags, such as also the dry run, to just see what would happen if we run this component generator. So here you can see we'll place that component in its own folder directly in our application. Now, if we run this without a dry run, it would generate this component for us. Now you can find all these options that you can pass to this generator here directly on our docs. But there's also a possibility to install the NX console plugin to have a more straightforward way of exploring these, especially a more visual way. So if you would generate the same component with NX console, we can just click here, generate, say component from that NX Angular plugin, and then give it the name again here, which is Hello World. We specify here a project, which would be my ng app, which is the main project that we have in this workspace. You can see a live dry run window being displayed down here. And now we can provide some further options, such as giving it the standalone flag. Again, you see the dry run live down here in this window. And once you're good to go with this, you just hit run here. And now it would generate a new component here in our source folder, app hello world. And if you open this up, you can see this is a standalone component that can directly then be imported in another standalone component and be used on your Angular application. So the next important step to know is obviously, how do I build my application such that I can then deploy it to some server? If you go back again to our package.json, you can see there is already a build script linked here as an npm script, but there's also the project.json where you have the build target directly linked in here. And so based on what we learned previously, we can run the build script just by using npx nx build. And this would now create a production build of our application and place that in that dist folder up here. So you can see the dist folder here, my ng app, and this contains now the bundles of our application that we can then just copy to some static web hosting and serve it to our users from there. Awesome. So with this, you now learned the basics of using NX in such a standalone, basically single project mode with Angular. You learned how to create initial project setup. You learned how to serve the application. You learned about the NX.json and how the project.json is kind of slightly different to the Angular.json, how caching potentially works, as well as how we can build it and then ship it to our user base. Now, you could stop here, but there's obviously much more to explore. So I would like to go a bit more ahead if you want to stick around with me and show you how NX can provide even more value to your Angular development by modularizing your code base with local libraries, adding some boundary rules, and finally then ship it again to our users. So if you're ready, stick around and let's go ahead with the second part of this tutorial. So when you use the Angular CLI to develop Angular applications, what often happens is that a lot of the features are co-located in this single application. And so ideally you have them structured by folders that correspond to your domain areas of your app and have them all situated in here. Now this can lead up to being very monolithic in terms of the code structuring, and also folder boundaries are not really as strong as you might sometimes want them to be. Now in NX we suggest a different approach, and this is particularly because NX allows you to create so-called local libraries which come with a public API that allows for a much better control in terms of defining boundaries. So what is private to that library and what in turn you want to expose to other libraries or to your application. So let's have a look. Again, what I would want to do is generate new libraries. And so I can do that by running again nx generate to add nx angular. And this time I give it the lib generator name. Now the name of my library here, the first one would be products. I also want them to be placed in a specific directory. Now I could have them all at the top level here. So one folder for products and all the other libraries I want to create, or just co-locate them somehow and organize them in one or multiple folders. Now in this case, I'm just going to go with a modules folder. I also want to have the standalone API to be used with these libraries. And ultimately, I also want to give it a simple name flag, which generates a more compact version of the component names. We can again use the dry run just to make sure that generates exactly what we want to have. And what you can see here is, as expected, it creates this modules folder. It would have the products folder, and in there it would generate some initial components and some additional setup. So let's remove the dry run and generate this library. You can now see here we got this products library. It also comes with its own jest config, its own ESLint config, meaning that you can also then run linting and testing for just this product library. It also has some product components here generated for us that we can use as a starting point or just remove them and generate new ones, again, potentially using the generators that come with Nx. It also has such an index.ts file, and this is basically the public API for your library. So here you control what components or other type of utilities you want to expose to other libraries and your application. And so this gives you a very good control point of what should actually be just private and what should be exposed. Now let's also generate another library that we call orders. And we might potentially also want to have another one that is called UI. And this is supposed to be some shared utility library for our UI components, for instance. So I'm also placing them in a subfolder shared, which specifically communicates to other team members that this is supposed to be shared across libraries and potentially multiple applications even. So what we got now is the following structure here. We can also explore them in Nx using the Nx graph, either within VS Code here using Nx console, or you just run Nx graph and then you can navigate here to this port and hit this show all projects, and you would now see the structure of this application. Now, right now, these are not connected to our application at all and are simply projects that live within the same workspace. Let's now connect them to our application and import them. When we generated all these projects, what happened as well is that here the tsconfig base got updated. And in particular here, the section about the TypeScript path mappings with some aliases that directly point to these index.ts files that I mentioned earlier. So this now gives us the advantage of being able to directly import these libraries into our application by just referring to these TypeScript path mappings rather than relatively navigating to the index.ts file, which obviously in the long term helps with maintainability of our code base. So let me go to our application, and we already have here a routes file configured. And so what I would like to do here is specify a couple of routes and import our libraries over the routing mechanism. Obviously, you could just also import the component directly if that better suits your specific needs. And so first of all, we would have here the initial path that directly just maps to the Nx welcome component. Next, I would like to import the products and orders libraries. So again, we can say path products, and that would directly load the component because we used here the standalone API. And so I directly import here from my products library that we generated before the products component. And similarly, I can do the same for our orders component. And I would rather import this from the orders library here. And obviously the component here is named orders component. Let's also remove here the static import that VS Code accidentally pulled in. Now, if we again use the graph, we should be able now to see the difference if we refresh, in that we now have our libraries connected to our application. You also see here the information about whether this is a static link, which means we would directly import the component into another component, for instance, or whether we lazily or dynamically load it, which is indicated here with this dotted line. And if you click on it, you can also see where exactly this is happening. On the other side, the module shared UI is still not referenced anywhere, and therefore it's not connected to our application. So to finish up our lazy loading setup, let's go also to the app component and remove here the direct reference to the Nx welcome component. And let's also go to the corresponding template here and remove the components, such that in the end we just have the router outlet left. Now, if we serve our app, and if we then navigate to our localhost 4200, at the root, we still see the component, the welcome component being loaded. But if we now go to products, it should load out the products component, which just prints product works. And similarly, the orders component should also work. So by modularizing our code base with these local libraries, we already got a much stronger boundary between these features. And so if we properly separate our applications based on their domain area or business context, this should give us a much nicer isolation and help with maintainability. So compared to folders, this is already much stronger. However, nothing prevents me from really importing from any other libraries, granted they re-export the components that I want to import. And this could sometimes even happen accidentally because VS Code just auto-completes some import based on some util function that multiple workspace products might have. So for this exact purpose, Nx introduces a concept of so-called boundary rules, and they are implemented as lint rules such that you can define which of these projects can depend on which other projects. So how you define these boundary rules really is up to you, and NX is really flexible such that you can add your own system. Now, what has proven to work well is by adding kind of like two dimensions. The first being which type of project can depend on which other type of project. So a project type is basically a library that is of type feature implementing an entire use case, or a library being of type UI because it hosts maybe order components that are being used in these feature libraries for our order use case flows. It can also be a shared library, let's say our design system that is shared across multiple of these projects. And the second dimension is usually the scope of the project. So whether this belongs to the orders domain or the products domain, or whether this is of scope shared such that it can be reused across multiple projects. Now, to classify these projects, NX has a mechanism of tags. So if we go, for instance, here into our modules orders file here and open up the project.json, there is a tags array that you can specify. And these are really arbitrary strings. So again, we can now represent these two dimensions. We can say this is of type feature and of scope order. Again, these are just strings that you can define. You don't even have to use a colon, but you could use a dash or something else that works better for you. Similarly, we can go to our products project.json and add here that this is of type feature and of scope products. And our shared UI library would be of type UI and scope shared. So this is a classic example of a library that is potentially usable within all the various projects that we have. So now that we have classified these projects, we can define the actual rules. And this is done at the root level ESLint file here in this ESLint RC base JSON. So there you can already see there is a rule defined for this module boundary ESLint rules that comes with NX. And so we can add here further rules. First of all, let's specify that the source tag of type feature can only depend on libraries that also have type feature, or we want also to have the type UI be able to be imported in a feature library. So these, as you can imagine, are the top level user flow implementation libraries. So they depend on potentially a lot of those other types of libraries. For instance, if you would have another library of data access for data fetching or some logic libraries or util libraries, you might also want to allow a feature library to depend on this. Contrary though, for instance, if we define the type dimension for our UI library, we might want that a UI library can depend on another UI library, of course, but we might not want it be able to depend on a feature library because the relationship should be rather vice versa. So the UI libraries tend to be more at the leaf side of our project graph tree. So now that we have defined the type dimension, we can go ahead and define potentially our scope dimension. So we can say here of scope orders should be able to depend obviously on other scope orders libraries. It should potentially also be allowed to depend on scope products because maybe the orders library needs to import the product lists to visualize in the recent orders that you have taken. But the products might not necessarily need to be able to depend on the orders. Now again, these are just constraints that we impose here in this demo tutorial. And what we also want to have is probably that it can depend on scope shared because maybe we want obviously that type of scope to depend on shared UI design components. And similarly, we can also define the one for our products. And so for products, we would want it to only be able to depend on products because we don't have any further domains here. And finally, there's the leaf node here, which is our scope shared, which should only really be able to depend on scope shared. And so once you have these rules in place, let's test them. Let's go to our products component library and try to import orders, which in theory should be prevented by this rule. And so if I go to my product component, and this again lives here in this products library, and I try to import here the orders component, you can already see these squiggly lines, and if I hover here, you can see that it indicates that a project tag with scope products can only depend on libs tagged with scope products or scope shared. And so this is really nice if you have the linting extension installed, so you get it right away when you import a component. Obviously on CI, this will block you as well, because you might potentially run a command that runs linting. For instance, I can do run many-t lint. This would run linting for all the different projects here. And for one of the 5 targets it's failed, which is specifically the import that we did here in our products component library. So that's it. Congrats! You should now have a pretty deep understanding of how to leverage such an NX standalone project setup together with Angular. Now, obviously, there is more to potentially learn, and some next steps can be, for instance, to explore recipes about adding Tailwind, how the storybook integration can actually be really beneficial for, let's say, developing our shared UI component design library that we used in our demo, but also how to speed up CI, because one of the next steps would be to set up a CI system and run the NX builds in the most efficient way possible. Also, make sure to, first of all, subscribe to our YouTube channel. We publish such videos regularly, so you don't want to miss out on those. Also, connect to our NX community Slack. So there's a lot of people hanging out there helping each other, which could especially be handy if you run this tutorial and have some further questions that come up. So I hope you really enjoyed this tutorial and you learned a lot, and I'll see you potentially in one of our next videos.